Now, we also have what's known as list comprehension. Okay, so list comprehension does the same thing as map and filter, the map and filter functions that we looked at before. But again, list comprehensions provide a more concise way to create a new list from an existing list. Okay, so on this slide, this is the basic syntax for a list comprehension, and it's a more complex syntax that includes another optional if condition after the opening expression. So we have this optional if condition. And in this example, again, we have a list of numbers. We make a list of 1, 2, 3, 4, 5, 6, and we call it numbers. And then we create an empty list squares. We initialize squares to an empty list. This is very common if you're going to manipulate some variable later inside a function to set up some structure that will end up holding it, right? So then we create this for loop in the append where we loop through numbers and we square each item and we put that into squares. Okay, so here let's, I think I have this on the slide too. This will be slide 48. And this is pretty straightforward. So here we set up the list of numbers. Here we initialize squares to be an empty list. We just use a simple for loop and the append method, which we looked at previously for the squares list. And it appends the square of each of these numbers to squares. And then we use a list comprehension that creates a list of squares. Okay, so let's give this a run. And again, if we take a look at squares when we're done doing that, so it's this list comprehension statement that actually creates this output. Okay, so what else can we say? Note that if you use a list comprehension, you have to use the same name variable here and in the for loop. Okay, so again, this example performs the same task as the map function example seen previously, but you don't have to have a separate function for squaring the number. Okay, so we just use this for loop instead of having a squares function. Okay, here's a list comprehension example that uses an optional conditional expression, which is here. And so what this will achieve, this is similar to the map function again, but the map and filter functions, but you don't have to explicitly create a function that will output even squares. We're just using the if statement, the if condition within this list comprehension. And what it does, it will simply apply this to every even numbered element in the list, because that's what this achieves. If there's no remainder, if you divide the number of the element by 2, it will trigger for that element only to be squared. Okay, and again, why would you do this? Well, you're just using a single line of code to map and or to filter the list. Okay, so here's another example, yet another example of list comprehensions. that does call a function. You can use it to call functions. For example, if your map and filter functions are complex, however, using functions can make your list comprehension more readable. Okay, so this example shows how to use functions with a list comprehension. Here, the expression for the list comprehension consists of a call to the square function. Okay, so we define square up here, which just simply squares a number. And here's our list comprehension here, right, our statement. And we are both calling the square function, and we are also using the conditional if statement within the list comprehension to call the is even function. Okay, so, and again, you need to be consistent about what you're calling the variable that you're manipulating. Okay. So if that's not enough, you can also use assignment expressions. If you remember what assignment expressions are, they use what's known as the walrus operator. And when you use an assignment expression, you can use the variable that is assigned a value by that expression in the expression for the list comprehension, right? So in this case, the variable is passed to the square function rather than the in variable from the for statement. Okay, so again, these get to be kind of a little complex, I suppose, and especially using assignment expressions, I find them to be kind of confusing because they not only assign a value to some variable, but they also set up a conditional, set up a Boolean statement, right? So we're only applying this action to num if it's true. That is, if the get number result is less than or equal to 6. So let's run this and then take another look at what's going on. This is what, this slide 51. Okay, if you recall what rand range does, rand range will randomly select a value in between the lower and the upper 1 to 10. Okay, so what is the rest of this doing? Well, we set up the square function that just simply squares a number, and then we set up a so-called get number function, which will just grab a number in between 1 and 10 and return that random value. Okay, but down here in our list comprehension statement, what it's doing is it is applying it is applying the square function to only the numbers that are selected that are equal to or less than 6. Okay, so what does that mean? Well, let's run this. And let's look at squares. Right? And so we ended up with this. If we run it one more time, I'll just grab, no, I need to do the whole thing. If we run it one more time, and we take a look at squares, this time we get 9, 36, 1, 16, 1, 4, and 25. If we do it one more time, repetitively, so we can note a couple of features about this. And we take a look at squares. Note that each list that was created are different sizes. And note, if you do the simple math in your head, you'll notice that all of the numbers that are in the output here are obviously squares of numbers that are 6 or less. 6, 5, 4, 3, 2, 1. Okay, so what it's doing here in this line, every time you run it, you'll get a different set of numbers for squares, and there will always be squares of numbers that are 6 or less. So even though it's selecting numbers in the range up to 9, if the number is greater than 6, it doesn't square it. Okay, so that's what's going on here. And again, this particular example, if you take a look at it, you may scratch your head and say, huh? But if you're writing a complex program, this can be a much more powerful and concise way to achieve a given result than trying to create different functions using for loops and so forth. Okay, so granted that the list comprehension stuff gets a little, what's the word I'm looking for? Detailed and maybe a bit opaque. But again, the point is the value of them are that if you're a detailed coder, being able to use like reduce and list comprehensions can save you a lot of time. Okay, because they roll in the power of doing it into a more concise way. Okay, so tuples. So why did we spend so much time talking about lists and less time talking about tuples? Well, to begin with, what a tuple is, it's a sequence that works much like a list. So you can use many of the same skills that we learned when working with lists. But the critical difference between tuples and lists is that tuples are immutable, which means you can't change the contents of a tuple without completely destroying it and creating another one. So you can't use any of the methods for adding, modifying, removing items from a tuple that you can use with a list. So methods like append won't work. Methods like pop won't work. Insert, none of those things will work. So you can create a tuple with syntax similar to creating a list, but you use parentheses as you see up here instead of the brackets. So it's really easy to remember how to create a tuple versus how to create a list. And as we'll see soon, it's very easy to make the distinction in creating a tuple or a list with that of creating a dictionary. Okay, so tuples, all you do is you put the elements in there. Note that they don't have to be the same data type. Often they are, because you'd be processing data that has a similar type, like we do here in these examples. These are all floating point numbers. These are all string variables, but notice here, as we saw with the movie lists, we have a string name for the movie, we have an integer for the date that it was released, and then we have a real number for the price.